Hello, everyone, and welcome to Tier 1 Interventions podcast. You may be listening to this on any podcast platform that you choose, but we encourage you to listen and watch this podcast on YouTube at Tier 1 Interventions podcast. I'm your host today, JZ, Jonily Zupancic, my partner host, co-host, co-author, Cheri, occupational therapist, is not with us today, but you've probably heard her on many other episodes. I am your math specialist, math coach, math girl, bringing you part 2 of a special series that we have been releasing on this podcast. This series is called 3 Math Rules That Never Expire. There was an article published in 2014, and to give credit where credit is due, the article by Karp, Bush, and Doherty, I know I'm mispronouncing that, and so someone will enlighten me as you are listening to this podcast. But the article, as to credit those 3 authors in 2014, was called 13 Rules That Expire. The premise is 13 math rules that expire as kids move to more complex number situations and into secondary school. A couple of the rules are things like when you multiply, you get a larger number. When you subtract, you get a smaller number. Those rules only work in certain instances. And in mathematics, oftentimes we will make a conjecture or a rule, and we have to decide whether that rule is always, sometimes, or never true. So it's really good. Any statement we make as an educator, or any statement that students make mathematically, these statements we call conjectures, and we are trying to prove or disprove conjectures. But any conjecture or statement that we, especially as educators, make, we need to ask ourselves and the students, is this an always, sometimes, or never? So play the always, sometimes, never game. Because with the subtraction rule that expires from the article in 2014, the rule meaning when you subtract, you get a smaller number, that's only sometimes true. And whether you want to venture into the sometimes that it's not true with younger students is entirely up to you. But we recommend, with our progressions of 3 math rules that never expire, that we introduce students to these concepts at an exposure level. We're not expecting them to master it, but exposing students to these concepts and mindsets as early as preschool and in the toddler years. The 3 math rules that never expire are these. Number 1, division is counting. So this is very easy as kids are toddlers and preschool age. Counting, rote counting with no meaning, 2, 4, 6, 8, who do we appreciate? Division is just rote counting and skip counting. Division is also counting through sharing, and we talked about this in part 1 of the episode. But rule number 1 that never expires, division is counting. Rule number 2 that we're going to address today, subtraction is distance. Yeah, subtraction is takeaway. Subtraction is many other things. Subtraction could be an opposite situation, but subtraction is distance, is transferable and progressive. It creates a good transformational progression from preschool through high school. It's the same no matter what types of numbers you're using. And that's what's powerful about these 3 math rules that never expire. The third math rule that never expires is multiplication is rectangles. We are going to address rule number 2 today. Subtraction is distance. If you are listening to this podcast, audio only, I will be sure to let you know the visuals that others are seeing. But if you want to see the visuals and the note taking, hop on over to YouTube, Tier 1 Interventions podcast on YouTube, and you will be able to see the note page and the examples. But I'll be producing them through speaking, so you have the auditory connection as well. But Subtraction is distance. You are going to, if you're watching this, see a notes page that's called Intro to Subtraction, Cycles for Grades 2 through 10. And I highly recommend that we use this in earlier grades than grade 2, but definitely, absolutely as is in grade 2. What we mean by subtraction is distance is just these 4 problems. These are the only ones I'm going to address today because this is an intro. As a matter of fact, if you are interested, if you're listening to this podcast on the day that it is released, tomorrow evening, when I say tomorrow, when this is going to be released, tomorrow is going to be January 15th. It is a Wednesday. We have a live session on this tomorrow night that you can be with us live on Impact Wednesday. We're going to extend on this topic, Intro to Subtraction, and talk about the importance, but the complexity of number lines. And we won't take this podcast to that level. But join us tomorrow night on Impact Wednesday. We'll put the link in the podcast notes, in the show notes. But if you can't find the link, go to Eventbrite, Eventbrite, eventbrite.com, and search for Minds on Math, and you will find registration for Impact Wednesday. It is free, but you must register to get the Zoom link. Today, we're going to focus on these 4 problems: 9 minus 2, 2 minus 9, 1003 minus 998, and 9 minus -2. And yes, this entire cycle is appropriate and necessary for grades 2 through 10. And we have one of our certified coaches that is a first grade teacher that also dabbles in these same numbers just for exposures. It's important to note that when we define subtraction as distance, it just becomes a counting exercise. All we are doing is counting, and I'm going to show you in these 4 examples. So if younger students don't get the exact count number but can get close, this concept of subtraction is distance is helping them with estimation of subtraction problems. The accurate and precise answer using procedural notations and processes is not the goal here. The goal is to improve number sense and understand closely how far apart numbers are, because that's the pure definition of subtraction. So let's take a look at this. We'll make this a little bigger. We're going to look first at the problem 9 minus 2. And as we look at 9 minus 2, that minus sign actually is a number line. It is the indication of where we go from and to on a number line. So if we physically make the subtraction symbol a number line by drawing arrows at each end of the subtraction symbol, we are signifying that we are trying to find the distance between the second number, which is 2, to the first number, which is 9. So we want to know what is the distance on a number line from 2 to 9. So if I draw a larger number line and I place 2 and 9, wherever, except we have to place them so that 9 is further to the right. The subtraction problem, every subtraction problem, means that the second number is our starting number. So we're going to start here on 2 on our number line, and we are going to figure out what the distance is going to 9. Now, we have to make a special note because we're starting at 2 and going to 9. We're going in the positive direction. Distance cannot be negative. Distance can only be positive, but direction can be positive or negative. So the distance between 2 and 9 is absolutely the same as the distance between 9 and 2 as in the next problem, but the direction is going to be different. So the sign, positive or negative, of the answer is going to be different depending on the direction, and direction matters. Oftentimes in 7th grade, teachers will have students walk a number line when they're learning integers. And we sometimes equate walking backwards with a negative, and that is creating a misconception. Walking backwards still creates a positive distance. Distance is positive whether we're walking forward or backward. We're still covering distance. So the distance is always a positive number, a positive concept. We can walk forwards or backwards. That's irrelevant. The way that we go left or right on the number line determines whether our answer, our result is going to be positive or negative. Direction can be positive or negative. Distance is positive. Now, this actually moves into the concept of absolute value. So in creating this progression of subtraction as distance, starting in preschool, when we get to absolute value, which is a distance, but this time it's a distance from 0, students have a really great foundational concept. So the distance from 2 to 9, we could do 2 to 5 is 3, 5 to 9 is 4, 3 and 4 is 7. The distance is 7. 9 minus 2 is 7. 2 minus 9, I can actually use the same exact number line because the distance is going to be the same. We start with the second number. So this time, 2 minus 9, we start at 9 now. So I'm going to star that with red because this time we're starting at 9 and we're going to the number 2. So if we start at 9 and go to the number 2, we're moving in the negative direction. We're moving to the left. We can also do the number line vertically, so we can go up and down instead of left and right. And I would suggest with subtraction, we change between one and the other, toggle between those. If we're starting at 9 and going to the number 2, the distance is the same. The distance before was 7. The distance is still 7. However, because we went to the left in the negative direction, the answer to 2 minus 9 is going to be negative 7. We're going to use this same strategy, this same thinking, this same mindset is really what it is. We want to ingrain this number sense mindset in students that every time they see subtraction, it's distance. When I look at this third example, we see 1003 minus 998. I turn the subtraction symbol into a number line by putting arrows on the left and right of the subtraction symbol. And by definition, we start at, I think I said 999, but I meant 998 if I said something different. It's 1003 minus 998. So the second number is 998. That means we start at 998 on the number line, and we're going to go to 1003, and we are trying to figure out the distance between those two numbers. If I start at 998 and move to 1003, my answer, my result is going to be positive because I'm moving to the right in the positive direction. I'm starting at 998, landing on 1003, and if I count up 998, 999, 1000, it's 2 counts to get to 1000, and from 1000 to 1003 is 5 counts. So the distance is 5, and this is a really good process for kids that are just learning about larger numbers. It's really a great process even for our 5th, 6th, 7th, and 8th graders and high school students who have never really mastered the procedure of stacking and subtracting with regrouping, borrowing, because if you stack these numbers 1003 on top of 998, there's a lot of room for error in crossing out, borrowing, moving through that procedure. We want kids to master that procedure, but the fact is about 5, maybe 10% of our students really struggle to master that procedure. And by secondary, middle school, and high school, still don't have that procedure mastered. So we want to make sure that as they're attempting to master the procedure, or as we're showing them the procedure, or as they're trying the procedure, they can also relate it to subtraction as distance. And when you do the procedure, you should get a positive 5. And if you don't, there's a flaw in the procedure. So using subtraction as distance to help confirm results from the procedure. Now, if we look at this final one here, and this is even important for our 2nd, 3rd, 4th graders, even kids before negative numbers need to be mastered, they need lots of exposure. This problem is 9 minus negative 2. The minus sign, again, is our number line. We put an arrow on the left and right of the subtraction sign. So it turns into 9 and negative 2 are my two numbers. My second number is negative 2, and I want to know the distance from negative 2 to positive 9. This is where we really get the power of this mindset, belief, and strategy of subtraction being distance, because this is transferable to all age levels, all grade levels, and all number types, even decimal, fraction, negatives, etc. So if I put -2 to the left of 9, I could kind of estimate in here where 0 would be. That's a good exercise for kids. And you can see, because this is much less procedural and very much conceptual, this is the exact exercise we need to improve number sense for our students. So just the exercise of plotting this and trying to figure out close to the distance, not even the exact distance, is a way for students to understand number better. We know that number sense is an innate, intuitive understanding, an inborn understanding, and many of our students do not have this innate, inborn, intuitive understanding of number, and they cannot be explicitly taught that. The only way we can improve number sense is through experiential learning, and for students to engage in the process, engage in the experience. And this process is exactly that. So you see here, cycle A are these 4 problems, and you can actually get this. There will be a link to how to get this in the show notes if you want a copy of this notes page of examples from today's podcast. However, we do have a package bundle for purchase that not only will you get cycle A, but you'll get cycles A through almost Z, 4 problems in each cycle. And you will have this to use with your students and with your facilitation. The number selection is important. So can you make up your own 4 problem cycles, your own cycle sets? Absolutely. But the ones that are made here, if you end up getting the bundle, are very deliberate and intentional with the numbers that are selected and the order that the numbers are selected. I won't go into detail why. There is a rhyme and reason to the selection of the number and the order. So let's go back to our final example. We start at -2. This is a 0. It kind of looks like a degree symbol. We start at -2 because that's the second number, and we go to 9. But guess what? We're going to the right. So my result, my answer, my difference is going to be positive because the direction is positive. And the distance then that is always positive, if I go from -2 to 0, there's a distance of 2, and from 0 to 9 is a distance of 9. So there is a distance here of 9 and 2, a distance of 11, and the result is positive 11. Play around with this, create your own cycles, give it a try this with students. This is the part 2 of a series of 3 math rules that never expire, appropriate for preschool through high school. And these cycle sets are completely appropriate and necessary for grades 2 through 10, but try these with your first graders as well. Again, this is part 2 in a series of 3 math rules that never expire. I am your host at this Tier 1 Interventions podcast, Jonily Zupancic, and until next time.